Alright, y'all, test tomorrow. So radical equations, solving the following, showing all work. Don't forget to check for extraneous solutions. So I'm going to do them by hand and also in the calculator. We're not going to do all of them in the calculator. Excuse me, sorry. But just a reminder on how to do them in the calculator. So remember, always get your radical alone first. So the radical's alone. So once the radical's alone, you square both sides. Square root cancels squared, or squared cancels square root. 1 squared is 1. Subtract 5 from both sides. A equals -4. So to check our work in the calculator, square root of -4 plus 5 gives me 1. So this is a solution. So it goes in fancy brackets. Okay. Number 2. There's no symbol in between, which means multiply. So the opposite of multiplying is dividing. So I get square root of m plus 3 equals -9. Now remember, I told you this, when it equals a negative and the square root's alone, it's going to be extraneous. Okay, so we square both sides. We get m plus 3 equals 81, positive 81. A negative squared, because you'll put it in parentheses, is always a positive. Subtract 3, subtract 3. So 81 minus 3 is 78. So m equals 78. And we plug it in. It should be extraneous. -2 square root 78 plus 3 should equal positive 18, but it equals -18. That's not the same. Therefore, this has no solution, and it has an extraneous solution at 78. Remember, extraneous solutions go in parentheses. Okay. Number 3, radical's already alone, so we're going to square both sides. We get x minus 6 equals 49. This cancels that. And then I add 6 to both sides, and x equals 55. Okay, so we plug it in. This should work. Square root 55 minus 6 should equal 7, and it does. Therefore, this is a solution. Okay. So number 4, we have a radical alone on both sides, so then we can just square it, and that cancels both of the radicals. So we get 3n minus 1 equals 4 minus 2n. And now we need to get all the letters on one side and all the numbers on the other. So I'm going to add 2n to both sides. This gives me 5n minus 1 equals 4. So plus 1, 5n equals 5, divide by 5, n equals 1. So square root 3 times 1 minus 1 gives me that. And then the square root 4 minus 2 times 1 gives me the same ugly decimal, therefore it is a solution. Now this one, is just like that one, except we actually need to move it over. So we want the equal sign in the middle. Well, how do you get rid of a subtraction? You add. So then this goes away and it looks just like that. Square root 3x plus 25 equals square root 10 minus 2x. Square both sides. That cancels that, that cancels that, and we're left with 3x plus 25 equals 10 minus 2x. So now we solve it just like we did here. So we're going to add 2x to both sides. That leaves me with 5x plus 25 equals 10, minus 25 minus 25. That leaves me with 5x equals -15, divide both sides by 5. X equals -3, so let's check it. So square root 3 times -3 plus 25 outside of the house minus another house 10 minus 2 times negative 3. And this should all equal 0. And it does, therefore that is a solution. Sorry, that's kind of messy. Okay, here, number 6, we're going to move the 2 over. We get square root of x plus 3 equals negative 2. When it's a negative, you're going to have an extraneous answer. So square both sides. We get x plus 3 equals 4, minus 3 minus 3, x equals 1. So let's double check. 1 plus 3 plus 2 should equal 0, and it does not. Therefore, there's no solution, and it's extraneous at 1. Alright, look at number 7. Sorry guys, it's a Monday, but we got this. So, number 7, we have to get the radical by itself. So I'm going to add x to both sides. That goes away, but I still have to get rid of this 4, so I'm going to subtract 4 from both sides. So I get square root of 2x equals x minus 4, and now I square both sides. Square root cancels your squared, and you get 2x equals x minus 4, x minus 4, and then we're going to double distribute, so x times x is x squared, x times negative 4 is negative 4x, negative 4x, positive 16. A lot of y'all messed up right there. Then I have to make it equal 0. Well, I'm going to combine these. So I get 2x equals x squared minus 8x plus 16. I'll subtract 2x from both sides. And I get 0 equals x squared minus 10x plus 16. So I'm going to bring this over here. I know that's kind of backwards, but... So I need to factor it. So A, B, and C. A times C, 1 times 16 is 16. C is negative 10. So remember, you can do this in your calculator. Sorry, I turned it all sideways. Top number divided by x. So 16 divided by x. 16 divided x plus x. Second graph, look for the bottom number here. So there's a positive 2, 10. So here's negative 10. Negative 2, negative 8. So then we rewrite it as 0 equals x minus 2, x minus 8. Okay, and technically I'm supposed to set these both equal to 0 and solve, but we also know that when we do that and there's nothing in front of x, it's just opposite. So x equals positive 2, x equals positive 8. So when we plug them in, square root of 2 times 2, minus x, which is 2, plus 4, should equal 0, and it doesn't, so that's extraneous. And then redo that, but with 8 instead of 2, and that does equal 0, so that is a solution. So it's going to be written 8, 2. Do not put the no solution sign, because technically there's a solution of 8. Okay, I've had a lot of people trying to put the no solution sign there. Okay. So here, we're going to square both sides, because the radicals are alone. And we get 3x equals 2x plus 9. Subtract 2x from both sides. And we actually get 1x equals 9. So we can check our work. Square root 3 times 9 gives me an ugly decimal. Square root of 2 times 9 plus 9. Which also gives me the same decimal, so this is a solution. Now, I'm going to show you how to do this one in the calculator. Remember, you have to have your radical alone before you can type it in the calculator. So the left side plus the right side. And you're starting where it says error, so there's my error, and we're looking for where they match. So if you look right here, do you see how they match but they're opposite? That means that's an extraneous solution. So we know there's an extraneous solution at negative 4 because it's the x that's our solution. Now let's see, oh, and right here they match perfectly, so my actual solution is negative 1. There's your answer, just from using the calculator. Okay? So I showed you all how to do one by hand, number 7, just like that. And now I showed you how to do it in the calculator. So let's try number 10 in the calculator. The radicals alone, so square root 3x minus 11, x minus 3, second graph. So here's the error. So right here they match at 4, and again they match at 5. So 4 and 5 are both solutions. Don't let these throw you off. It just means a radical. It's the same thing as writing square root of x plus 10 equals 8. So we're going to square both sides and get x plus 10 equals 64. Subtract 10 from both sides, get x equals 54. So when I plug this in my calculator, I'm going to type it just the way it was originally. 54 plus 10 to the 1/2 power. This should equal 8, and it does. Therefore, that is a solution. Okay, let's look at this one. Again, just square both sides. That cancels, and I get x minus 11 equals 4, plus 11, plus 11, x equals 15. Plug it in. So 15 minus 11 to the 1/2 should equal 2, and it does. So that is a solution. Okay. Okay. 13 says a function y equals f of x is shown on the graph. Based on the graph, what is the solution to the equation at f of x equals 3? Well, f of x equals 3 is just y equals 3. This is my x-axis, this is my y. So y is 3 here at this height, and that touches at -4. So x equals -4, and this is a solution because it touches. So I know this one is worded very poorly, but the table of values represents several points of a square root function. What is the best estimate of the solution to the equation when the solution is equal to -1.8? So when it's, which one of these is closest to -1.8? It's right here. So my answer is x equals -5. Okay, crime scene investigators can determine how fast a car was traveling by measuring the friction marks, braking distance left by the car on the road. The scatter plot at the right shows several possible values along a function compared the speed and braking distance of a particular type of vehicle. What function best fits this data? We actually don't have a test question like this, but you could type these in your calculator and look at the table, not the graph. So 21 square root x, second graph. So we have a point at like 40 and 30. So are these at like, sorry, 40 and 30? No, that's way off. So we know it's not A. So then we could try inside the house. That's about 40 and 30, so this one is a maybe. So then this one says add 10, but that's almost 40, so that'd be like 40 and 40, which is wrong. And then we could do the last one, 10 square root x plus 21. It's about 40 and 80, so that's wrong as well. So C would be your answer. Now you do have a test question like this one. So for the scatter plot above, which speed would most likely cause a braking distance of 120 feet? This is your braking distance. So braking distance at about 120, I would say would be approximately 50. Okay, remember this equal sign means 50. So 50 miles per hour. Okay. All right, let's look at the back. The function t equals 2 pi square root of m over 9.8 gives the period t of a pendulum in seconds in terms of the length m in meters. So if the pendulum is 1.5 meters, that means we're going to replace the m. So t equals 2 pi square root of 1.5 over 9.8. Well, guys, there's no unknown, so type it in your calculator just the way you see it in your home screen. 2 second, this little caret top is pi, square root, alpha y equals enter, 1.5 over 9.8. So my answer is 2 point, so what does it say round? It doesn't say. So we're just say 2.5. So the period is 2.5 seconds. Okay. So then it says if the period is 5 seconds, then what is the approximate length? So now we know time is 5. 2 pi square root m over 9.8. So we have to get rid of the 2 pi first. And it's multiplying, so we're going to divide both sides by 2 pi. So we get 5 over 2 pi equals m square root of 9.8 over 9.8. I don't know if I said that right, but whatever. Okay, I need to square both sides. So alpha y equals enter. 5 over 2 pi squared, because I'm going to square both sides, gives me 0.633. This is round to the nearest tenth. So that's just like 0.6, but I'm going to keep it up. So 0.633 equals m over 9.8. So now I'm going to multiply both sides by 9.8. So I'm just going to hit multiply 9.8 because it is the answer, and it's we'll say 6.2. Okay. Let's look at number 18. The diameter d in inches of a rope needed to lift the weight of W tons is given by the formula. How much weight to the nearest pound can be lifted with a rope with a diameter of 2.5 inches? So diameter is d, so 2.5 equals square root 15W over pi. So if you notice, the pi is not inside the house. See how here that they are both obviously under the house? This is not under the house. So I'm going to multiply both sides by pi. So I get 2.5 pi equals square root of 15W. So I'm going to square both sides. And I get 2.5 pi squared, 61.69. Equals 15W, so divide both sides by 15 and divide by 15, I get 4.11. So W equals 4.11. Okay. Number 19. The formula S equals square root of A over 4.828 can be used to determine the side length of a regular octagon with an area A. To the nearest square meter, what is the area of an octagon with a side length of 6? So side length is S, so 6 equals square root of A over 4.828. So I'm going to square both sides, and I get 36 equals A over 4.828. I'm going to multiply both sides by 4.828. That cancels, and I get A equals 36 times 4.828. 173,808. So okay, let's look at number 20. A company manufactures cans for pet food. A half-gallon can of food with a height of 3.5 inches contains about 75 cubic inches of dog food. If the radius of the can is determined by this formula, where V is the volume and H is the height of the can in inches, what is the approximate radius of the dog food? Well, I'm given the volume and the height, so I'm filling in that. So R equals, volume is 75 over height is 3.5 pi. And since there's no unknowns on that side of the equal sign, I can just do it in the home screen. 75 over 3.5 pi. And that gives me 2.61. Or round to the nearest hundredth, yeah. So radius equals 2.61. It says the speed of a tsunami or tidal wave or can travel is modeled by this equation, where S is the speed in kilometers per hour and D is the average depth of the water in kilometers. A tsunami is found to be traveling 146 kilometers per hour. What is the average depth of the water? So that's our speed. 146 equals 351 square root D. So I'm going to divide both sides by 351. And I get square root, I'm going to flip this, equals 146 divide 351, 0.4159, or we'll just say 416. And now I'm going to square both sides. And my answer is 0.17. Okay. Last but not least, you don't need to do these domain and range problems. Oh, you need to do the top, just not the domain and range. So let's just write the equation for the graph. So here, it shifted right 2, up 1, 2, 3. So right 2 is an I-HOD change. So remember I-HOD over. So this is left and right. This way is minus, this way is plus. Up and down, up is plus, down is minus. Okay. So this went right, or right 2. So right 2 is minus, and that's inside. So y equals square root of x minus 2. And then it went up 3, and that's on the outside. And remember, it went up 1 over 1 for the first change, so there's no multiplication, there's no expansion or compression. Here it went down 1 over 1, so it flipped vertically, okay? So vertical is outside, so y equals a negative on the outside. It went right 2, and it went down 1. So I'm going to put a little hook so y'all know where my house stops. Now this one flipped horizontally, okay, which means it flipped over the y-axis, which is an inside change. So y equals square root of negative x. And then it didn't go left or right, but it did go down 3, so minus 3 on the outside. Last but not least, this one shifted 1, 2, 3, 4, 5 left. Y equals x plus 5, and then it went up 1, 2. Alright, test tomorrow. If you have any questions, let me know. Bring me questions for your test, preferably. Y'all have a good day and good luck. Y'all are going to do great.